So I want you to go ahead and, okay, to find the point that's going to optimize, and I want to define that real quick. It is the point with greatest y value. Oh, they're coming to get you. I like the window. I'm really missing out, right? Okay. Let's get back. All right. So our optimization for the first graph is on the very top. Basically, it's the vertex, and specifically, it is what of the vertex? Is it minimum or maximum? Maximum. So let's do a word problem that has to do with a specific scenario. So Macy, let's read number 4.
An online business sells backpacks. When they price a bag at $60, they sell 500 backpacks. For every dollar they add to the price, they lose 5 sales. Find the price of the backpack will optimize the revenue by following the steps below.
Part A?
You want me to read A?
A.
Okay. The function Rx is equal to 60 plus x times 500 minus x to 5x. Represents revenue. Rx that the business takes for every x increase in price. Describe why this function represents the scenario.
So to find the revenue, it's going to be how many bags do I want and how much is it each, correct? So in this case, 60 plus x is representing how many item or the price?
Right.
That's the price. Then what is 500 minus 5x representing?
Backpack sold.
So it's a quantity, right? So can I say the number of backpacks? So let's go on to part B. It says to find the zeros. If y'all remember, like 4 terms that would represent zeros was either roots, solution, and what was the other word? X-intercept, good. So for us to find that, I need to take each factor. So in this case, we have 60 plus x, set that equal to 0. I also need to take 500 minus 5x, also set that equal to 0. So our first one is going to give us x equals how many? Negative 60. And our second one, let's just do the math. Negative 5x is equal to negative 500. And when I divide it by negative 5 on both sides, how many is my x? 100. So it's going to cross out those 2 points. Now, the way I graph this may not be drawn to scale, okay? But I'm going to do my best. So let's say this is about negative 60. And maybe that's about 100. Oh, there you go. Nope. So I said 60, I wrote 60, I meant 6. No, it should be 60, right? 60. Whoa, what was happening? Okay. So we know the graph is going upward or downward. Do we have a minimum or maximum?
Maximum.
We have a maximum, so I need the graph to look something like, oh, I hope it's even, like this. And not only that, if you were to multiply this out, your highest power is going to say y is equal to negative 5x squared. And y'all remember when you had the value that was negative in front of the x squared was pointing downward from last year? Okay, if you're like, whoa, here it is. Y equals x squared looked like this. And then y is equal to negative x squared look like this. And our highest power has a negative in front, so it's got to be going downward. So let's put a dot at the maximum. So we know from negative 60 to 100, the total horizontal length is 160. And we have a symmetry exactly halfway through. So if I were to cut this in half, cut that in half, that will be 80 and 80, right? So if I go 80 units from 60, what is that x value for the maximum? 20. And if you even find the midpoint using geometry, it'll give you 20 as well. So we know the graph is opening up or down? Opening down. And how did we find the x value again? We took the average. And that's basically the definition of the midpoint. And that was 20. So now that I know it's going to be 20 at that maximum. Could I plug that 20 back into the function? Yes, I can. Let's see if I have room. Let's plug it in. We have 60 plus 20 times 500 minus, could I just say 100? And that's going to give us 80 times how many? 400. And what is 8 times 4? So I could just write 32 and add as many zeros. So we have $32,000. And then it says, now find the price of the backpack. Now this is a revenue. This is how much you're going to make. And we said the price of the backpack was 60 plus X. So backpack is going to cost how much? 80 bucks? Is it 80 for the backpack?
Yeah.
20? Okay, yeah. Boom. So we're paying 80 bucks per backpack, and the company will make $32,000. Sounds pretty good. Good morning. It's okay, enjoy the view. It's okay. All right, we said 6, right? All right, let's go to 6. Stephen, let's read.
A gardener has 100 yards of fencing enclosed a rectangular space for a village. He is building it next to a river, so one side is bordered by a river and does not need fencing. The other 3 sides will. Draw a picture representing his garden. Write a quadratic equation representing the situation, and find the dimensions of the garden that will optimize the area.
So he's got a river, and he does not want to cover the river, correct? So we can enjoy the water. So the fencing is going to be in like 3 linear dimensions. So here's my garden. So how you label this doesn't matter, but I'm going to say these 2 are my width, and that's my length. You can change them around. It doesn't really matter. So we know the fencing is going to take about 100 yards. Is that 100 yards pertaining to the perimeter or the area? Perimeter. So we know we have 2W plus 1L must be 100. Questions there? What are we maximizing? The area. To find the area, isn't that length times the width? Yep. So you have 2 options. I can either solve for L or solve for W. Which one's going to be faster? Solve for L. L is almost by itself anyways. So we have 100 minus 2W. So now that I have this, I could take all of that and plug it in here. So we know the area that we're going to maximize is going to be in 1 letter term. So there's 100 minus 2W times another W. To find the zeros, and I'm going to put this in parentheses. Just like I did on the previous one, we're going to set both parts equal to 0. So if I take 100 minus 2W equal to 0, and W is also equal to 0, so that part's already done. So solve for W on the first one. How many? 50. So let's go ahead and graph this. Ooh, they're back. Okay. Oh, goodness. So we have 0 and 50. And we know the graph is going to go, are we going to have minimum or maximum? Maximum. So that's our maximum. So halfway between 0 and 50 is how many? 25. And again, in case you're like, how do we know it was a maximum? When I take my variables, and my highest power ends up being negative 2W squared. It is negative, so it's pointing downward. Okay? So what can I do to find the area then? Well, it says to find the length and the width, right? Should we plug it back in? So we know our width is going to be 25. The length, when I plug it back in, it's going to give me 100 minus 2W. How many would that give us? 50. And that will maximize the area. Is there units on here? Yard? Boom. Final answer. So when y'all get to number 5, let's say the river is not going to be considered as part of the perimeter, then I guess we could, let me rephrase that. If there's not a river, we could say 2W plus 2L is equal to the perimeter, okay? And that might be the method on number 5. All right, let's go on to number 8. The wordy number 8. Emma, let's read.
Okay. Side AB of a rectangle lies on the x-axis where the vertices must be somewhere between A and B. Another horizontal side of the rectangle is defined by points C and D, which lie on the straight lines y equals negative 2x plus 12 and y equals 2x plus 12 respectively. Find the maximum possible area of rectangle ABCD. Should I read that?
Mm-hmm.
Okay. And draw an axis and the functions choose points C and D randomly to create a horizontal line so you can draw a sketch of the rectangle. Label point C as x, y, and go from there.
Hayden, were you listening? Do we need to read again? Okay. I'm going to summarize. Let's make our axes. And let's grab the 2 linear functions. So the first one, both of them is going to go through what? Y-intercept. 12. Now, if I know the slope is negative 2 and 2, we know every 2 that I drop, we're going to go to the right one. Is that right? Yes? So in the end, let's assume that I did all of that since I'm sketching. What number will it cross on the x-axis for those 2 functions? 6 and? Negative 6. So let's go ahead and connect them. So here's my negative linear function, and here's my positive linear function. And it says to put something for AB and something for CD. It really doesn't matter where you put it, but all we know is that it's going to make, what kind of shape does it say? A rectangle. So why not just go ahead and split it right here and go straight down, and there's our rectangle. Let me see if I can highlight this. So this is our goal right here. So let's go ahead and say this equation is y equals 2x plus 12. On the right, we have y equals negative 2x plus 12. And then I know according to the coordinate plane, because we're at the origin right here, it's going to be denoted as x comma y. Okay, any questions on the labeling so far? Yes?
No, could you move the paper up, please?
Up this way.
Yes,
Okay.
thank you.
All right. Let's talk about finding the area in general. If I want to find the area, it is length times width. Is that right?
Yes.
Now I want you to notice something. From here to here, it is x. So what would it be if I go from the corner to corner horizontally? 2x. So let's write out area is equal to 2x.
Wait.
Because it's symmetrical on the other side. And then let's go ahead and take the other one. From bottom to top, the bottom y value is, it's really dark. The bottom y value is 0. If I go up to y, it's just going to be y. So if you want to write out y right here, that would be nice. So now let's go ahead and plug in what we know. Good morning. We have 2x. For my y, which function am I going to use to optimize? The positive slope or one with the negative slope? With a negative slope. So we have negative 2x plus 12. And can we go to set them equal to 0 again? Just like the other one, so we know where it's going to land at? Our first one, if I have 2x is equal to 0, my x has to be how many? 0. And then on the next one, if I set negative 2x plus 12 is equal to 0, what would that give us? 6. So let's do our quick sketch. So here's my 0, here's my 6, and the graph is obviously, again, going to go up and down with the maximum. What number can I predict for that midpoint? 3. Since I'm looking for the y value, I need to take the 3 and plug it back into what? Right here. So when I do, I get y is equal to negative 2 times 3 plus 12. And that's really negative 6 plus 12, right? So what is our y value? 6. So now I can go back up here and say, well, what is the maximized area? So in this case, 2 times my x. So 2 times my x is my 3. The y that we just found is 6. And that's going to give us how many? 36. And do we have units for this one? Nope. So could we just say u squared? Voila.